Okay, this chapter is titled From Ape to Human, the Emergence of Hominins, which are basically our ancestors and us. The book has no figures in the chapters, this one and next one on the evolution of behavior. So I'm going to just take figures from various sources like Encyclopedia Britannica to make the same points. The big question, of course, starts by asking what is it that makes us modern human? The definitions are not very quantitative in that sense, so we will look at various morphological features like here height, jawbone structure, the skeletal structure, cranium, and people also include symbolic representations, language, opposable thumbs, ability to build tools, and so on and so forth. So let's start by looking at this figure, which goes here, Homo sapiens, and let's say we're starting with our earliest ancestors like Australopithecus. We'll see more details in a minute. There are various species of Australopithecus along the way. So Australopithecus afarensis, we'll look at the timing of these things. Homo habilis, who was smaller, Homo erectus, who was anatomically almost like us, and then we've had Homo neanderthalensis in the middle as well, and the debate still goes on about whether based on the body structure and the face and so on, and the cranium, whether they were as smart as us or not, why did they go extinct, whether they interbred with us, the Homo sapiens. So you look at the Homo sapiens, so everybody who is present now in human form is obviously Homo sapiens and fits into this definition of modern human. So if you look at the variations of various morphological features, nose, chin, jaw, teeth, skeletal structure, cranium size, and so on, you can look at the variation, and then anytime you differentiate ourselves from other previous ancestors of ours, we call them a different species. This is not always based on genetics. So there could be genetic differences, developmental differences, morphological differences, and obviously the definition species means those that don't breed with each other, right? Different species don't breed with each other, and a species fits into one box when it can breed with each other. So if these interbred, then are they really different species, or should they be combined into one species? So all kinds of detailed questions remain. So here is the opposable thumb kind of argument, how we are different from let's say gorillas and chimpanzees, bonobos, whoever you want to think about, and our own ancestors like Australopithecus. You can slightly see the difference here in the hand versus Homo habilis, especially Homo erectus and Homo neanderthalensis and Homo sapiens have a different thumb than Australopithecus afarensis. The precision of grip, which then allows various skills to develop. There is Australopithecus afarensis. The skull of afarensis is similar to that of the modern chimpanzee. So obviously we are not direct descendants of chimpanzees, but we will see that in a minute. So you can see the cranium size getting larger with Homo erectus from Australopithecus to Homo sapiens. Jaw and teeth got smaller. The argument is that the muscles that hold the jaw together are so strong in, let's say, gorillas and chimpanzees that their cranium size is limited by that, whereas either through evolution or there is arguments that maybe some gene went missing by error that released the jaw and teeth muscles and allowed our cranium to grow bigger. So basically that means you don't always have direct evidence for things, and various hypotheses are built based on whatever fossil evidence one finds. So the timelines keep changing and the narrative keeps changing as well. So here are the tools going back hundreds of thousands of years, and then the question is whether we were really the most skillful ones in doing this. Even now there are various animals and birds that build and use tools, so whether this is something special to us. But it is clear that such sharp stone tools were used for killing, hunting, gathering, fishing, etc. And because of the opposable thumb, we are also very good at throwing things very far, like a spear, for example. So there is definitely something in the evolution. And then you have to worry about features that are different just morphologically versus genetically, whether the features are passed on genetically or they were just phenotypic response, for example, some kind of a response of the same gene pool but different environment. So those are also not always resolved, whether it's just genetic change or phenotypic change. So there is a question of adaptation and adaptability. The adaptation can be genetic adaptation of Neanderthals developing certain hair, thick hair for a kind of skin to survive in the cold, versus us who don't have as thick fur as even some of the chimps and gorillas, for example, and so on. So if you just compare Neanderthals to modern humans, lower, larger cranium, larger bow bridge, larger nose, larger shoulder joint, larger, broader rib cage, larger elbow joint, broader hips, shorter forearm, larger hip joint, larger and thicker patella, shorter and more flattened tibia, and larger ankle joint. So now you're comparing various features to distinguish Homo neanderthalensis from modern humans, and it is clear that they interbred. So once modern humans, our ancestors, got out of Africa around 60,000 years ago, they met the Neanderthals and interbred with them, and all humans at present, the sapiens, carry some percentage of Neanderthal genes, for example. That brings up a question of whether the current Homo sapiens, some have more ancient genes than others, are some more modern than others, and so on. So it gets kind of subjective and argumentative and qualitative and so on and so forth. Okay, and it's also not very clear why Neanderthals went extinct as opposed to sapiens who survived, and by all accounts they were present till very recently, just about 26,000 years ago. So it isn't entirely clear why they went extinct. Looking more specifically here at brain capacity in cubic centimeters versus time, millions of years ago, this gives us a better sense. So drawings of specimens here are to scale, and you can see the cubic centimeter brain capacity goes from 300 cubic centimeters to 1500 cubic centimeters, and here we are, Homo sapiens arriving more recently in time, but Homo neanderthalensis spanned similar brain sizes. Homo erectus was smaller here. Homo heidelbergensis, which seems to be the origin of various modern species before we came along, we will see that in a bit, had a higher, a lower cranium size compared to us as well, and this shows the time span they covered. So Homo erectus was around for well over 1 million years, whereas Neanderthals were only here. Sapiens are here, Neanderthals were here. So far similar amount, but we're still here and they're not here. Homo habilis, Homo ergaster, Homo ruralfensis, Australopithecus afarensis, which we talked about before, which survived for a while in various species. So Australopithecus garhi, Australopithecus robustus, Boise, and so on. And here you have chimpanzees and gorillas still present, with their cranium being much smaller than us as well, and differences in thumbs as well. Okay, so let's leave this here. Basically, I have said many things and yet haven't defined exactly what makes us modern humans versus the others, but we will leave it there because this is not a very quantitative, subjective, it's not a very quantitative, objective definition. You can read a lot about it, but considering this is going to be a course on climate and human interactions, we don't have to worry too much about the details that are still debated. So I just wanted to give you a sense of these things as I go along. Okay, so I'll leave it here and come back and look at some of the timelines of evolution before we move on to evolution of behaviors, and then come to climate and try to match the climate perturbations or climate change along the way to the evolution of humans. And idea is still the same, that when climate changes and many new environmental niches are opened, species that are adaptable can take over and survive or evolve if they can battle the existing dominant ones, for example. So adaptation is again genetic, whereas adaptability could be simply like finding ways to stay warm in a cold weather, for example, by inventing fire or inventing clothes made out of animal skin, and so on and so forth. So there is difference there in terms of genetic versus cultural and behavioral evolution. Okay.